Our last speaker today is Cheryl Hung, Senior Director at ARM, and Cheryl's going to give us a quick run through of where we are at the moment and where we might be going. So, Cheryl.
Hi, everyone. Okay. Hi, everyone. Thank you so much for staying till the end of the day. I always know it takes a lot of energy to get through one of these events, so I am very pleased that you made it all the way through to my talk. I'm going to be talking about some of the key trends shaping the future of infrastructure. A little bit about me. I'm the Senior Director of Infrastructure Ecosystem at ARM. Infrastructure meaning cloud, telco, and networking. So I focus on ARM within big data centers and servers. I'm also the founder of Cloud Native London, which is a meetup group that has over 8,000 members. So if you're ever in London on the first Wednesday of every month, come and hang out with me. And I've also previously worked for the Cloud Native Computing Foundation, which is the open source foundation behind Kubernetes, Helm, Prometheus, many of the foundational open source projects in the cloud native sphere. Before that, I was an engineer at both Google and Apple. So I'm going to talk about 3 key trends today. The first one is Cloud Native Today. CNCF recently published a survey on 2023. So we're going to look at some of the key findings and analysis from that. I'm going to talk about practical cloud native AI. And if you are not yet on the AI hype train, then why it is now time that you should jump on. And then I'm going to talk about vendor-owned open source. So I imagine most people who work in technology companies use open source in some fashion. Going to look at some of the trends that we're seeing and what are some things to think about if you're concerned about those. So first one, cloud native today. So the CNCF survey was conducted between August and December of 2023, and it had just under 3,700 respondents, but we're going to look at the results from the end users. So this is excluding the Googles, the AWS, the Microsoft Azure, those kind of vendors. The respondents were pretty equally split between sort of small, medium, and large size companies. And the top job functions from the survey were SRE, DevOps engineers, software architects, and DevOps management. So the first trend that came out of this survey is the large organizations are starting to embrace hybrid and actually deploy it in real life in a way that it didn't really exist, or it was very, very difficult a few years ago. So if you look at the small companies, which are the kind of yellowish ones, they mainly focus on public cloud, whereas the ones in pink, which is the large organizations with more than 5,000 employees, tend to also deploy in a hybrid public-private kind of model, which makes sense because there's a lot of benefits to going hybrid, to diversify your infrastructure. But it has always been very challenging to do this. So what we're seeing here is a trend of this sort of really coming to fruition. CNCF hosts many open source projects. I mentioned Kubernetes. The ones that they saw the most increased usage between 2022 and last year were gRPC, Helm, and Prometheus. So gRPC is to do with communications. Helm is controlling the applications that are running on your system, and Prometheus is monitoring these. So these are very foundational activities, and they're still seeing growth. Conversely, the kind of approaches that we're not still seeing so much nowadays are things like serverless and FAS. These numbers are relative, by the way, so this is not saying this went from 100% to 60%, whatever. Serverless has always been fairly small, but it's starting to not really sort of be seen as much as it was. Service proxies and service meshes. So again, these are sort of the more secondary, perhaps auxiliary functions that we're starting to see less of. And then what are some of the leading challenges in cloud native infrastructure at the moment? So again, we're going to let's start look at the yellow ones. These are organizations that are just getting used to the idea of cloud native and Kubernetes. So the biggest challenge that they reported was the lack of training. Still lack of training, lack of expertise. If you've been working in this space for a little while, you might expect that everybody knows about Kubernetes or about cloud native, but that's definitely still not the case. But if you look at the pink ones, which are companies that reported that they do almost all of their deployment on cloud native, the biggest challenges are around security and around complexity. So there are more and more tools coming out in these areas, but this is still a challenge. Okay, let's look at practical cloud native AI. Oh, I have a clicker here. I might use this. Oh, nice. Okay, so what do I mean by cloud native AI? So cloud native AI is leveraging computing resources, particularly CPUs and GPUs, with isolation and controlled mechanisms to deploy, run, and scale AI workloads. And why do you want to do that? You want to do that in order to accelerate performance and reduce cost. This is nothing new in terms of why you want to run workloads in general. The big difference for AI is most companies do not have the scale or the resources to own as many GPUs as they would like to train all of their AI. So the only way for them to access the GPUs, the resources that are needed, are going to be through the large cloud providers for the most part. So this is roughly what an ML lifecycle looks like. I'm going to go over this in sort of very broad strokes, so not going to go into much detail here. But you have an ML engineer, you have some data preparation, you do feature store, some model training, you store it, and then you do some model serving, so you serve actual results from it. And then you sort of repeat this process round and round and round until you get to the kind of results that you're looking for. So there's a lot of challenges in this, and the major ones are that the size of the data is enormous, and the complexity of the computation is enormous. So this leads to all sorts of challenges down the road. Again, some of these challenges are not unique to AI, but they are much larger in scale than what we've seen before. And a very sort of straightforward one here is also cost control, because as I mentioned, GPUs are very expensive and most companies don't have the resources to manage them. Sustainability is also an interesting one. One of the reasons that I work for ARM is that, and I find ARM interesting, is that ARM has always been focused on low energy solutions, which is great for mobile phones, but also great if you have an enormous data center and you're consuming enormous amounts of electricity and energy in the world. So anything we can do to sort of reduce the amount of energy that we're using for these workloads is generally a good thing for the world. And then again, I stole this diagram from a white paper, the Cloud Native AI white paper that came out through the CNCF a couple of months ago. But broadly, we have predictive AI. So we have, is this a cat or is this a dog? And we have generative AI, create a picture of a cat dog. And then, so those are the kind of workloads that we have. We have that ML lifecycle that I talked through before. Underneath that is a platform, possibly Kubernetes-based. Underneath that, you have all the cloud providers. And then underneath that, you have the actual hardware, the CPU and GPU. And then on this side, we have the kind of personas that are involved. So you have a data scientist / developer, ML engineer, platform engineer, SRE, operations, and underneath all of that, the hardware architect. So if we're talking what does cloud native AI look like, so this is a rough overview of what it actually looks like in practice. I also wanted to point out, although I don't think it's very small, but I wanted to point out that there are a lot of solutions coming out around this to handle all of those challenges in terms of huge scale and huge complexity. So this is an area that's really, really fast moving right now. And I have some suggestions for you if this is something that you would want to look into a little bit further. One is to look, we're starting to see the emergence of AI engineering, or ML engineers sometimes, as its own discipline, its own job role, that combines some functions of data scientist and infrastructure engineer. Education for kids and students is really important. As I think Faisal asked, or someone asked, like, how many people use ChatGPT and have no idea what it is in the background? Lots of kids will happily use AI generated stuff and not understand what it means. So that's really important for us as well. I would suggest joining some industry groups. The Linux Foundation has an AI and data group, as does the CNCF. It has an AI working group. There are also meetups and conferences. and certifications through organizations like ACM and IEEE. And then lastly, safety by design. One thing that we've heard a lot about is how AI is going to codify these biases and complexities in the world. And there's organizations out there that are trying to fight this and make sure that people have control of their own data and people understand the results that are coming through from those. So if you're interested in it from that direction, I'd suggest that you look at the AI Alliance, the Internet Forum to Counterterrorism, All Tech is Human, and many, many more. Okay, third big trend that I've seen, vendor-owned open source. So this is the classic open source flywheel. This is what how open source is supposed to work, let's say. You have technology innovation, you have business innovation, and one drives the other. So on the technology innovation side, open source helps speed up the pace of innovation. It helps to drive adoption because people can adopt open source very quickly and improve reliability. On the business side, you pay for support. You have an open core model where you have open source base, and then enterprise pay for functionality on top of that. And you have SaaS, software as a service. And the idea is, one drives the other. And this has worked really, really well for the last 10, 15 years or more. The big change now that we're seeing is we're no longer in this low interest rate environment, and companies are having to tighten their belt and question how they're spending their money. So we're starting to see more and more companies that have open source as their business model relicense what that core is from something usually that is more permissive to something that is less permissive. So Mongo, Redis, Elasticsearch, they've all relicensed towards something that means it's not so easy to commercialize their work and not pay something back to the company that has put so much effort into it. Conversely, you also see some trends the other way. So Grafana has moved towards GPL, which is in theory more permissive, but then GPL touches everything that it touches also becomes GPL. So that's also more difficult, makes it more difficult for businesses to incorporate it into their commercial offerings. And then a few months ago, one of the CNCF projects, Linkerd, announced that the Linkerd code would always continue to be open source, but from future releases of Linkerd would only be available through Buoyant, which is the company that employs most of the maintainers of Linkerd. And this caused a little bit of an uproar because the idea behind open source is, yes, okay, the code is open, but people would always assume that meant if you wanted to use open source, that you would pull it down as a release, and then you could use that freely. So this is a big change because now this means you have to pay the company in order to get a stable release of this open source project. So if you use open source within your organization, here's a couple of questions that you could consider asking yourself. So one is, what open source licenses do you use? Are those more permissive or less permissive? Could you automate some of those checks? Could you incorporate those into your CI/CD pipelines? Who's behind the open source? So in the case of Linkerd, Buoyant is a single company that controls a lot of what Linkerd is, because by virtue of employing most of the maintainers of Linkerd. And in general, we see this as a positive behavior because we want maintainers to be able to work on open source and be paid for their efforts. But at the same time, then it leads to the single companies like this being able to make big changes that the community might not agree with. And the last question is, what is the governance policy behind this? So for example, Linkerd has a steering committee, but that steering committee is not made up of community members who can actually influence the behavior of the project. It's set up mainly as an end user forum. So for end users to give feedback on what the project is and its features. So it's worth looking into some of these issues if you use open source and consider what the company is. And I don't mean this as a negative. I don't want to sort of demonize any company like Buoyant or anything, because the truth is a matter of fact. The truth is that they need to survive. as I said, this business and technology flywheel, the idea was always the business needs to be able to make money in order to invest back into open source. So it is not a bad thing that companies want to make money from the open source work that they've done. But you as a user of open source should be aware of these issues and should be aware that the companies may make changes to what they're doing very quickly without any other notice. So that is it, the 3 key trends. So first one that we talked about was cloud native today. We looked at the survey from CNCF and looked at some of the challenges and the solutions that are coming out in cloud native. Second is the practical cloud native AI. So we had a look at what is cloud native AI, what does it mean for you, and then why you should look into it and some places to look at if you're interested in more. And then thirdly is the vendor-owned open source. So the trend of relicensing open source projects, and then some questions to ask yourself if you are interested, if you are using open source and want to be on top of that. That is it. Thank you very much. Finally, always tell that song.
We have a short period of time in which to ask a few questions of Cheryl, if you have any. Does anybody have a question? Not at all? Oh, somebody there?
We need a microphone, I think.
Sorry, can you keep your hand up, please? If you, oh, there you go. There you go, right. Right, it's coming up on your other side. Thank you.
Hi, great talk. Thank you very much. It was very informative. I'm curious about companies and in general people using vendor-provided ML or AI models. So do you think there are risks with that? I mean, companies are blindly trusting vendors with those models. So, and if so, if there are ways to mitigate those risks when those companies maybe don't have ML AI experts that can provide advice.
So the question is whether there is risk involved with the ML models being controlled by these large companies.
Yeah, exactly.
Yeah. So absolutely, right? The EU actually has recognized this as a problem because most of those major tech companies are based in the US, and most companies in the EU will be using those, which means that we no longer have control over those base models within the EU. So the EU itself actually has several initiatives to try and fund some models within the EU. I'm a little bit dubious about how likely this is going to work out, because I'll be honest, I think the EU a few years ago ran a project called Gaia X, which was also recognizing that we should have a large cloud provider in the EU, and that also hasn't worked out, basically. But it is absolutely a risk, and unfortunately, it's one that requires a lot of money and a lot of talent to fix it. So no easy solutions.
Sorry. Oh, blimey. Could you explain to me, as a non-industry insider, what is the nature of that risk? If I use, basically the intellectual property of somebody in America to develop something in Europe, what is then the problem?
The problem is we have slightly different regulations in the EU around it. So, for example, GDPR is an EU directive because the EU has decided that it is worth controlling data owned by European users within Europe. The question is, is it necessarily a bad thing to have data stored elsewhere? Perhaps if it's in the US, then the US government can have access to all of European users' information and data. It's very hard to pinpoint an exact problem, but yeah, in general, it's a question of risk. It's a question of who has access to the data. Could you retrieve your own data if you wanted to? What if someone in the US moves that data somewhere else to a third country that you have no access to at all? Yeah.
So basically, the perfectly reasonable assumption that if something bad can happen, it probably will at some stage.
I think risk is, I wonder if there are any insurance people here. Maybe the insurance people would like to answer that question. Risk is not, absolute, if something terrible is going to happen, it's going to happen. It's a question of what actions can we take at the moment to mitigate that.
Okay. Lady there.
Hi, hello. Yeah, it's Rachel again. Actually, I think I know some kind of a risk that because our company help the chip design semiconductor company, their engineer for R&D to accelerate their R&D process. And when they meet some situation like they design using some tools to some image, there will be some risk about the network transmission rate like from different site from American, US, or the Europe side, and their team, multi-team should work together, and that's the network transmission rate will be very essential. Yeah,
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 absolutely. Yeah. So, yeah, network is one of those is one of
yeah.
the phases where somebody could access
Yeah, and we do a lot
that.
about to help the engineer to uh, help them to use the cloud well, more easy, and to the more efficiency, but there's still a lot of risk. Yeah.
Mhm. Yeah,
Okay.
yeah.
Thank you for that. Would you be kind enough to pass that microphone forward to Faisal, please? Thank you.
Nice presentation, Cheryl. Just to give the answer to your question earlier about the data, what's the problem with using the IP from US and developing something here? At the end, everything boils down to the money. You will not be able to monetize anything if it's owned by somebody else. So one of the key reasons for actually controlling the data is to have the ownership of that data. So you can actually build the models which can be monetized later on in the future. If you don't do that, then you don't have the right to do that.
Okay. Thank you very much for that.
It's we could take this sort of to an extreme and say
Yeah.
you are the only person that can hold your data. Everyone's going to carry around a little box with all of their data in the future, and
Yeah.
then you'll have perfect control over it. So there's definitely a trade-off between how much personal privacy or control you have over your data versus who has access to it once it's controlled by somebody else.
It's worth bearing in mind. Folks, can I ask you to thank Cheryl one more time, please? Thank you.
Thank you very much.